Hello, very good morning and welcome back to the next video installment of electrical power generation and economics. In this gas turbine power plant number 2 video, we are going to learn more about gas turbine, its compressor and its working, and many more things about its principle. In the previous video of this subject, we have studied the advantages of gas turbine power plants over diesel plants. We have studied that developed per kg of air is more than diesel plant. And less vibration due to perfect balancing and no reciprocating parts. Less space required, capital cost is less, higher mechanical efficiency, and running speed of the turbine is large, and the lower installation and maintenance cost. Continuing with the same topic, let us extend the topic. The next point with this topic is the torque characteristic. The torque characteristic of turbine plants are better than diesel plants. It is actually very important to note the torque characteristics of this turbine plants are better than diesel plants. We are actually comparing gas turbine power plant with diesel power plant. The next point, the ignition and lubrication. The ignition and lubrication systems are simpler. This one is another advantages. The specific fuel consumption, that is in short form it is written as SFC, that is a specific fuel consumption, does not increase. Please mark it. Does not increase with time. टाइम के साथ ही इंक्रीज नहीं होता in gas turbine plant as rapidly in diesel plants. Whereas in diesel plants it increases. So gas turbine power plant has got another advantages as comparison to your diesel power plants. The next one is poor quality fuel can be used. Yes, in gas-based power plant or gas turbine power plant, poor quality fuel can be used. The next point is lightweight. It weighs light. Lightweight with reference to weight to power ratio is less for gas turbine power plants. The next point is also very important, and that is smokeless combustion. Combustion is your non-polluting. Combustion is your non-polluting. Smokeless combustion is achieved in gas power plants. It has got complete combustion. The smoke left over is zero, so it is non-polluting. It is polluting very zero. It is non-polluting. It is very prominent advantages of gas power plants as comparison with your diesel power plant. Now, next topic is disadvantages of gas turbine power plants over diesel plants. The first point is poor part load efficiency. The second one is special metals and alloys are required for different components. This is actually very costly requirement. Special metals and alloys are required for different components. It is the design and manufacturing requirement. Special cooling. Special cooling methods are required for cooling of turbine blades short life. The next point is the thermal efficiency is low. The thermal efficiency is theta thermal is low. We have seen this. The next point is wide operating speed. Wide operating speeds, the fuel control is difficult. Needs to have speed reduction devices. For higher operating speeds of turbine. Difficult to start a gas turbine compared to diesel engine. It is difficult to start a gas turbine as comparison to your counterpart, your diesel engine. Next one is manufacturing of blades is difficult and costly. Manufacturing of blades of turbine is difficult and it requires lots of money. The next one is same output gas turbines produces the 5 times the exhaust gases than IC engines. Let us move towards advantages of gas turbine power plants over steam plants. Now we are going to compare the available steam plants with your ongoing gas turbine power plants. We will see first the advantages of gas turbine power plants over the existing steam power plants. The first point is from environment point of view, no ash handling. This is very obvious. We have studied this point in previous slide also. There is no ash handling. The next point is low capital cost and running costs. The third one is space requirement is less as compared to your steam plants. This is an advantage. The next point is fewer auxiliaries are used. The number of auxiliaries used in gas turbine power plants as compared to steam power plants are very much fewer. The time required to build this gas turbine power plant as comparison to steam power plant is less. That is, it can be built relatively quicker. The next one is can brought on load quickly to support peak loads. This is important and should be noted down. Can brought on quickly on load and it is used to support peak loads. thermal efficiency of the gas turbine is higher. The thermal efficiency of the gas turbine is higher. It is higher than steam when working on top temperature, that is greater than 550 degrees centigrade. Temperature greater than 550 degrees centigrade. The gas turbine plants quite economical for short running hours. These gas turbine plants are quite economical, but for short running hours. One should be noted. It is for short running hours. Next point is, the storage of fuel is smaller and handling is quite easy. Less cooling water is required for gas turbine plants as compared to steam power plants. Next point is, weight per HP is far less. It can be installed anywhere. The control of gas turbine is much easier as compared to the smooth controlling of your steam power plant. Let us move towards the next topic of this section is the gas turbine power plant layout with auxiliaries. We are going to learn about the layout of gas turbine power plant and what are the necessary auxiliaries it demands. See this? The point number one is, this is a point number one, and it is low pressure compressor. It is written here, low pressure compressor. Then move towards from point 1 to point 2, that is your low pressure turbine. Point number 2 is your low pressure turbine. From point 2 to point 3, we are moving from point 2 to point 3. Let's come to this point. Point number 3, this is your starting motor. Point number 3 is your starting motor. From point 3 we are coming to point 4. This is point 4, and the symbol is actually very much obvious. It is alternator. See this, point number 4 is alternator. From point number 4 we are moving to point number 5. This is your point number 5, and the point number 5 signifies the position. The name of this is high pressure compressor. This is your HP compressor, high pressure compressor. From point number 5 we are going to point number 6. This is your point number 6. This is your combustion chamber. Point number 6 is your combustion chamber. The point 6 is showing combustion chamber. From point number 6 we are going to point number 7. This is your point number 7, and point number 7 is your heat exchangers. Point number 7 is your heat exchangers. This is your heat exchangers. Heat is being exchanged here. This is your gas turbine power plant layout. This is complete layout of gas turbine power plant. And what are the main components of the gas turbine power plants or the layout are? The first one is your gas turbine. The second one is your compressor. The third one is your combustor, and the fourth one is your intercooler and generator. Let us repeat it once again. The first one is your gas turbine. The second one is your compressor. The third one is your combustor. This is your combustor. And this is your intercooler and generator. Let us move towards the next slide of this topic. This is a gas turbine. Specifically, we are going to focus on gas turbine. A gas turbine employs blades mounted on a shaft and enclosed in a casing. The blades are mounted on a shaft. The blades are mounted on a shaft and enclosed in a casing. It is given. Flow of fluid through the turbine is axial and tangential to the rotor. The basic requirements are lightweight, high efficiency, reliability in operation, and long working life. It is the basic requirements. The large work output can be obtained per stage with high blade speeds. When the blades are designed to sustain higher temperature higher. That is, the large work output can be obtained per stage with high blade speeds when the blades are designed in such a way to sustain higher temperature. The next point is more stages of the turbine. More stages of the turbine blades in the gas power plants helps to reduce the stress in the blades and increase the overall life of turbine. The overall life of the turbine is increased. Gas turbine blades are continuously subjected to the high temperature gases. This is very important. It is continuously subjected to high temperature gases, so we need to cool the blades for longer life. It is to be done on highest priority to increase the longevity of the blades, the gas turbine. Otherwise the life will be reduced. In air cooling, the air is passed through the holes provided through the blades. This is your simple gas turbine, the diagram of simple gas turbine. You can see the fresh air going inside the compressor. This is your compressor. Okay. The shaft of compressor and the shaft of turbine are here coupled, or you can have the same shaft. It means the rotation and this rotation is same. There is no relative movement. We have discussed this in previous slides or in previous video. From the end portion of compression there is a path connecting to the turbine, and in between this path there is a chamber called combustion chamber. This is fuel injected into the combustion chamber, and this is fed into the initial portion of turbine. This is the structure of turbine. This is the structure of turbine. This is the output of exhaust gases. At the end point of turbine there is outlet. From this outlet something is coming out. This is your exhaust gases. Exhaust gases are coming out of the turbine. The shaft of turbine and the shaft of alternator are coupled just to have same relative rotational motion. And this alternator is actually giving you RYB induced EMFs, and this is having a load starting motor. Working principle of gas turbine. It is like the air is compressed. The air is compressed to high pressure, to very high pressure by a compressor, and fuel and compressed air are mixed together in a combustion chamber and ignited. You can see in the previous diagram like this. See this is ignited. This is the symbol of ignition. This is ignited. And hot gases are given off, which spin the turbine blades. See in the diagram, hot gases are entering to the input portion of this turbine, and this turbine is having the potential to rotate. The work turbine is intended and designed for. This is hot gases are given off, which gives the turbine wheels rotational motion. The gas turbines burn fuels such as oil, natural gas and powdered coal. The gas turbines have three main parts. This is three main parts. The one is air compressor, the second one is your combustion chamber, and the third one is your turbine. Gas turbines have these three main parts. Without these three main parts, the imagination and the realization of gas turbines is almost very difficult. This is gas turbine power plant air compressor. The air compressor and turbine are mounted at either end or a common shaft, as we have discussed, seen in the diagram, with the combustion chamber between them. Gas turbines are not self-starting. A starting motor is used. Gas turbines are not self-starting, therefore a starting motor is used. Let us see in this our previous diagram. See this starting motor is given. This starting motor is given for what purpose? Because this gas turbine is not self-starting. नहीं है ये. This is not self-starting. To make it starting, a starting motor is provided. Okay, a starting motor is used. The air compressor sucks in all air around and compresses it, thereby increasing its pressure. What is the main functions of compressor is? Let us see this. The axial flow compressors are used in gas turbine installations. An axial flow compressor consists of a series of rotor and stator stages with decreasing diameters along the flow of air. The blades are fixed on the rotors and rotors are fixed on the shaft. The stator blades are fixed on the stator casing and the stator blades guide the airflow to the next rotor stage coming from the previous rotor stage. The air flows along the axis of the rotor. The kinetic energy is given to the air as it passes through the rotor, and part of it is converted into pressure, pressure. An axial compressor is capable of delivering the constant volume of air over varying discharge pressures. These are well suited. These are well suited for large capacities at moderate pressures. If the impeller of a centrifugal compressor is designed in such a way to give an axial component of velocity at exit, the design becomes a mixed flow type. Let us see the centrifugal compressor, what it is actually doing here. The compressor, this is our compressor. The centrifugal compressor is superior to the axial flow machine. In that high pressure, ratio can be obtained in single stage machine. Through at the cost of lower efficiency and increased frontal area. See this is a compressor diagram. Where it is. This is located here. This is the position. This is the position. You can see this. This is your only rotor shaft. This is your axial compressor, and this is your centrifugal compressor. Shaft. Inside the compressor there it is inlet. We have seen it. This is a burner, and this is your turbine portion. And this is your nozzle portion. This is all about with this video. We have studied in details the gas turbine power plants, and we have compared this with your diesel power plants and steam power plants. Steam power plant is basically your thermal power plant, and we have found and noted down various advantages and disadvantages over comparing with diesel power plants and comparing it with also steam power plants. We have seen the basic principle of the gas-based or gas turbine power plants. We have seen the schematic diagram. We have seen the compressor and your turbine. In between compressor and turbine there is combustion chamber. How combustion chamber is actually functioning, and the turbine is here not self-starting. So to make it self-starting, we have given a starting motor, and we have to take extra care of the shaft. Shaft is actually coupled together to have zero relative motion with the cascading devices on which it has been mounted, or you can have very intelligently same shaft rod, but it is not feasible to have same shaft rod, so it is piecewise having same dimension of shaft and mounted together. So go through all the concept of this video. Slowly you will be able to understand it, and it is very interesting to study gas power plant. In my next video I'll be coming with more renewable sources of power generation like wind energy, biomass and tidal also. Till then, thank you so much. Thank you for watching this video.